So I just wanted to point out a few things in this video for our circuit bending class that aren't covered in Nicholas Collins' book. So the main point is that everybody needs an amplifier to get your circuit amplified. It can cost $15 or $20 to buy a small battery-powered portable amplifier, so that's money. And to solder up your own amplifier, which uses an LM386 chip, which is also used here on this board, that can be very difficult to get right the first time. It's a difficult first project. So I've handed out these boards to people, which cost about $1 each, and they're quite simple to use. I'll just show you how they work. So these two terminals here connect to your speaker. The polarity does not matter. Polarity for audio doesn't matter, so you can put them in however you want. On the bottom here, you'll see there are 4 pins. They are labeled ground, ground, in, and VCC. So VCC will connect to the positive rail on your breadboard, so this goes to 9 volts. You can connect ground to either of these 2 pins, and then the output from your oscillator, or whatever audio circuit you're using, goes into the in pin. So on this board I have a Schmitt trigger already set up, and I already have pins or wires in place for my amplifier. So I'm going to go ahead and plug this in. And you'll see that this wire here at the far left connects to VCC, and it connects here to the 9-volt rail. This wire connects this pin to ground. And the only thing left that I need is input from my oscillator to the amplifier. And, of course, battery power. But let me plug this wire in first. So I'm plugging in pin 2 here of the Schmitt trigger to the in pin of my amplifier. And now, once I hook up my battery, I'll get some sound. Now this is a relatively simple circuit because I'm only using one of the inverters on this Schmitt trigger. It's called a Schmitt trigger because there are 6 inverters that you can use. So if you want to use a second inverter, there's an extra step you have to do. So in this case I'm going to use an electrolytic capacitor. These capacitors are polarized, so if you look on this side you'll see this bar, this little gray strip and a sort of negative sign. This side goes to ground. Polarity for a ceramic disc capacitor like this one does not matter. So I'm going to go ahead and set up a second stage here, pin 3 to the capacitor and then the other side to ground. I'm going to install a second photoresistor. This one is a little taller, it hasn't had its legs trimmed like the first one. Now the extra step here is that you need to pass the outputs of these oscillators through either resistors or diodes before they go to the amplifier. So in this case I'm going to use diodes because diodes do really interesting create a really interesting effect, which I think is much more interesting than resistors, which simply mix the sounds together. Diodes kind of create somewhat of a ring modulating effect, so I'll show you what that sounds like. And I should point out how the polarity of a diode works. This is a silicon diode. Each of you should have 8 of these in your kits. You'll see there's a little black stripe on one side of the diode. Okay, that side goes to the amplifier. Okay, so I'm going to plug this in to pin 2, and then I'm going to go ahead and bend the diode and get it plugged into the first, or the in pin of the amplifier. And then I'm going to do the same for a second diode and the second oscillator. This time it's coming from pin 4, but going to the same pin on my amplifier. And because I'm using a large electrolytic capacitor here, and this oscillator will have a much lower range, a lower frequency range than the other one. So let's hear what that sounds like. I'm turning it on. So you can hear what's happening. This oscillates at a much lower rate, and it sort of serves as a gate to let through the sound of the first oscillator. So that's a really interesting effect rather than just having them mixed together, which could also be interesting, but in this case this oscillator is now gating the first oscillator.